So today we are going to talk about the assignment 2, and we are going to exploit the dirty cow vulnerability. Uh, I would call it dirty cow attack. So before we jump into the details about dirty cow, I want to show you what dirty cow can do. So, so imagine that there is a library, and inside the library there is a public computer. All right, and this is its users hierarchy. So on the top, there is root, who has the most privilege of a system, and beneath that, there are some other users like Alice and Bob. And compared to the root, Alice and Bob have less privilege. Today, for example, Bob wants to say something bad about Alice. So the first thing he do is that he create a text file called gossip.txt. And then inside the text file, he writes Alice is uh, fat. Okay. And after saving the file, the second thing he do is to make sure that this file can only be edited by Bob himself. Other people cannot edit it. So in the command line, he typed chmod 644 and then the file name text. Okay, so the first digit means that only Bob can read and write the file, and then the second digit means that the people in the same group can read the file only, and the last digit means that other people can only read the file as well. So by typing this command, he makes sure that this file, this gossip file, can only be edited by Bob himself. Now, Alice sees this file, and then she wants to change this file, right? She wants to change this file because she think that it should be slim, not fat. So she's tried to edit this file, but apparently it doesn't work. Why? Because Bob has already changed the permission. Alice doesn't have enough privilege to edit this file. So what Alice wants to do, she performed the dirty cow attack. All right. She performed the dirty cow attack and then she tried to change the fat into slim, and she worked. So what dirty cow can do is that the dirty cow can bypass the privilege, like bypass the privilege check and then edit any file you want. So let's go to the second part, is that the TA demonstration part. All right, so in this part, we are going to create two users, right? Sudo add user. The first one is Alice, and then DEES, right? Opposite of C, right? Enter, and then enter the new password for Alice. 1234, 1234, everything by default. Okay, so Alice, our first user, is created. Now let's create our another user, Bob. Okay, same, 1234 for his password. Oh, I'll try again. What happened? 1234, 1234. All right, everything by default. Okay, so as you can see, um, there are two more users, right? Alice and Bob. Switch user to Bob because the first thing we want to do is that we want to create a gossip file. So password 1234. All right, so inside home, let's go to the Bob's directory. Okay, so inside Bob's directory, he start to create a file, clean gossip.txt. All right, and he writes something bad about Alice. Okay, Alice is fat. So he exit the file. Okay, so let's see what's inside the file. That's it. Alice is fat. Okay, the second thing he wants to do is to make sure that this file can only be edited by him, by Bob. Okay, so what you want to do is that he type changed 644 gossip.txt. It makes this file can only be edited by himself. Now, let's switch to another user, right? For example, today Alice logged into this public computer. So let's mimic that. So switch user to Alice. The password is 1234. All right. So Alice saw that Bob has this file, has the gossip file, and then she opened it, right? And she sees that, oh no, this is shouldn't be fat, it should be slim. So what you want to do, she wants to edit this file, right? She wants to try to edit this file, and she try to add it into something slim. Okay, but unfortunately, when saving the file, there is an error, right? This file can only be read only, so she cannot edit this file in other scenario. So what you want to do is she wants to perform the dirty cow attack. So let's go to let's go back to her directory, cd alice. Okay, so inside her home, inside Alice directly, we want to create a file called attack.bob.c. So let give me some time to type in some code to perform the dirty cow attack. Alright, so I just basically copy and paste the dirty cow attack file, right? And inside the file, you can see the target file is Bob gossip file, and beneath the file, we aiming at the position writing fat, right? Because we want to change the fat into slim. So here we can see after finding the fat word, we will change it to slim. So yeah, this is basically the three things you want to take a look at. The first is your target file, and inside the file, what is the target word? And then what word would you want to change to? So in this case, I think we have done it. Now let's compile gcc attack bob.c, and you have to add this command lp thread, and then output file I call it attack bob. Alright, so as you can see, under Alice folder, there is an execution file attack bob. So let's perform. Oh, so before we perform the attack, let's see what is inside the gossip file, right? So we want to print out the Bob gossip file to take a look at it again. Right now, inside the gossip file, it says the Alice is fat. So Alice wants right now is going to perform the dirty cow attack. So here we go, attack Bob. Now, give it a few seconds, right? One, two, three, four. Okay, then press Control C. All right, let's take a look at the gossip file again. Right? So as you can see, that the file has already been changed, right? The change to Alice is sleep. So yeah, so we have done it. So Alice have successfully changed the gossip file. Now, think about it. Today, Alice does not target Bob. Instead, she wants to target the root, right? Today, Alice don't want to be Alice anymore. Alice wants to be the root, right? So if she becomes the root, then this is very bad because it means that inside this system, Alice can do whatever she wants. In our system, there is actually one file. It's called its position at the etc and password file. Right, inside the file, it lists out all the users' privilege, right? For example, root, x, 0, 0, blah, blah, blah. And then, for example, Alice, um, x, 1,000, 1,000. So, if you are able to change this into 0, then you will escalate Alice as a normal user to a root user, right? For example, if Alice doesn't want to be Alice anymore because it has limited access to the system, she wants to become the root, then she can perform the dirty cow attack. To attack this file, change this number into 0, and this makes her a root user. So let's see how to escalate Alice privilege to the root. Okay. So inside the terminal, I will just clear it. All right. Let us take a look at the password file. I'll say cat, and then take a look at the password file. And I will, because inside the password file, there are lots of users, but I'm only interested in Alice, in Alice privilege. All right, so as you can see here, the number is not 0. So currently she doesn't have the privilege. So what we want to do is we will slightly modify the number over here. All right, the third field we will want to change it to 0. So let's modify the attack file again. Alright, so what I want to do is to copy the attack bob.c to attack, I don't know, root. Okay, let's do this. So let's modify the root, attack root file. So inside here, I no longer want to attack the Bob gossip file. What I want to edit is to attack the password file, right? And then inside the file, I remember there's Alice, and then X, and then 1003, and then 1004. And this time, I want to change it to, um, let's see, maybe Alice X1 0 0 0 0 and 0 0 0. Okay, so finish editing the file. Let's compile it, right? GCC attack root.c, lp thread, and then the output file attack root. Okay, so yeah, so this file is generated. So what I want to do is that I want to perform this attack. So now it is running. Give it a few seconds, maybe perhaps 3 seconds to 4 seconds. Right, so time's done. So press Control C to terminate the file execution. Right, let's take a look at the password file. Okay, password. I'm only interested in the Alice privilege. So you can see here. Now Alice has the 000 on the third and the fourth field. After changing Alice privilege, I kind of have to log out to become the seed user again. So terminal. All right. So currently I am a seed user, right? Let's take a look at the password file we just modified. Okay. So cat etc. Okay, etc password and grab Alice. So as you can see, in the last dirty cow attack, Alice has successfully changed her privilege to 0000. It means that she can gain the root privilege. So here we will switch to Alice. All right, password is 1234, and you can see when we switch it to the Alice account, she becomes a root user. One thing as a root user is that at the end of the right, I don't know, at the end of the line, there is the pound. There's this icon. Okay, so in this example, Alice used the dirty cow attack to modify the password file and then modify her as the root user. And so now she becomes a root. And remember this password file to the normal user, it is on read only. So today, Alice used the dirty cow attack to modify this file and to become a root user. Now, in the last part, we are going to explain why dirty cow attack works. Right? What is the problem? Like, what is the mechanism that cause this dirty cow vulnerability? So let me explain. All right, let's explain what's happened in dirty cow attack. So this is the memory. Inside the memory, there are many pages, right? Each of these code pages. It is like a small segment of memory. And in Linux, there is a mechanism called copy on write, right? COW. This COW is where the dirty cow, the cows come from. Okay, what it means is that if there are two or more process, for example, one process one, and the second process, these two processes try to access the same memory, right? And it is fine. They can share. They can share, use this memory. But if process one wants to write this memory, this is when the copy on write kicks in. Alright, Linux will perform the copy on write mechanism so that it will make a copy and then let the process one to modify in this private memory so that while process one is modifying inside this part, it will not affect the content that the P2 is accessing. This is called copy on write. And this is the first part of the dirty cow attack. The second part of the dirty cow attack is the race condition. What is the race condition? Race condition means that the two process or more process they access the resource at the same time. Like for in this case, P1 process 1 and process 2 retrieve the same number at the same time. So this is 1 and then the plus 1 becomes 2, right? The number becomes 2. P2 do the same thing. Process 2 do the same thing. Plus 1. So the 1 plus 1 becomes 2. So when they put it back, you will see the number is 2 instead of 3. But process 1 actually add a number 1 to the original number, so does the process 2. So in this case, the number should be 3, right? But here, instead, we got 2. So this is race condition. Race condition means that when two or more processes try to access the same result, the output may becomes unpredictable. It could be 2, sometimes 2, it could be sometimes 3. All right. So this two, the copy on write and the erase condition is the two fundamental part that cause the dirty cow vulnerability. All right, let's explain how dirty cow happens. So two fundamental part, right? Copy on write, and the second is the erase condition. So the first step is that we read a file into the memory, right? We read a file. Remember our first example that there's a file says the gossip file says Alice is fat, right? So our first step, read the file into the memory, and then the second step is that there are two threads created, right? One of the threads do the writing, right? Remember, this is the read only. This is the read only file. So one of the thread T1, we'll call it uh, thread one. What it wants to do, it wants to change the fat into slim, right? But according to the Linux, if you want to write to a read-only file, the copy on write will take place. So it will create a copy, and then the thread one can write it to the copy. It should be write it to the copied memory, right? This is thing and this is fat. So this is different. And the second thread will do mad buys and don't need it. It means that this thread is telling the kernel to discard the memory. In this case, the shared memory is over here. This is the shared resource and being continuously accessed by the thread 1 and the thread 2. All right. And this caused the race condition to happen. And to be honest with you, I don't know what happened to the kernel in this case, but I only can say the race condition somehow confused the kernel. And then the thread 1, instead of writing to the new copied memory, it write it directly to the original memory. This is why a normal user can write it into a file which he is not supposed to write into it. So this is as far as I know, right? What actually happened to a kernel is very complicated and I don't know how to explain. But as far as I know, the race condition when multiple process, right, like the last example, when multiple process try to access the same resource, weird thing can happen. Weird thing, right? In our dirty cow attack case, there are multiple threads try to access the same resources. So the weird thing happened. The thread one happens to write into the read-only memory. And yeah, so yeah, this is how it happens. In your assignment, I'll be impressed if you can explain what actually happened here very, very clearly. Yeah, and yeah, that's it. Right, so for your assignment, you'll be asked to complete the tasks list over here, like task 1, task 2. There are only 2 tasks, and just follow the step, right? The steps are very clear. You just follow the step and you can get the result. Yeah. So good luck with your homework.